My name is Kareem Khalifa. Today, we'll be looking at formal methods for universal introduction and existential elimination. Okay, we've already seen informal methods for universal introduction and existential elimination, but we wanted to hold off on showing the formal methods because those are a little bit trickier. But don't be scared, everything will be fine. Let's begin with universal introduction. So the basic idea behind universal introduction is this. You take an arbitrary instance of some given generalization. Now, because it's arbitrary, you can draw a universal conclusion from it. Here's a simple example. All dragons are reptiles. All dragons breathe fire, so all dragons are fire-breathing reptiles. So to prove this, we'd set up the problem as follows. We'd have a universal generalization for all dragons are reptiles. That's our first premise. Same thing for the second premise, except now all dragons breathe fire. And our conclusion is then for all x, if x is a dragon, then x both breathes fire and is a reptile. All dragons are fire-breathing reptiles. So recall, the informal way of doing this is we take an arbitrary instance of some given generalization, we derive a bunch of stuff, and from there we can generalize precisely because the instance is arbitrary. So what we now need to do is regiment this notion of arbitrary instance, and then everything else just runs pretty smoothly. So we're trying to figure out what kind of arbitrary instance that we need. And the best way to think about this is just to build in your proof strategies from the ground level, right? So obviously our main operator is a universal quantifier, and so ultimately we're going to need to do a universal introduction, but first we need to figure out what that arbitrary instance is. And what I do in this particular case is I look for the main operator on which the universal quantifier is ranging, or the scope of it, right? And that's going to be this arrow that's highlighted in this slide. So I'm thinking of this like an arrow introduction, and that means I should hypothesize my antecedent. However, if I do that, I'm not going to have a well-formed sentence. I'm going to have a well-formed formula, but not a sentence. So I'll just have dragon X, and that I can't do anything with that in the context of a proof. I need an actual sentence. And this is where you need to be a little bit more attuned to how different proofs sort of work together. Okay, so what I'm doing is I'm going to actually put dragon A as the hypothesis of my subproof on line 3. And how do I get that? Well, I'm looking at the thing I need to prove, which is for all x, if x is a dragon, ... I don't even need to fill that out. That gives me enough information to know that that's why I should be hypothesizing dragon A, right? And this is supposed to be my arbitrary instance, right? A is my arbitrary instance, or dragon A is my arbitrary instance. And we flag this in the proof by putting that little a surrounded by a box. It looks a little weird because of I'm using PowerPoint, but the idea is there's supposed to be a box around the A. Right, so I have A, dragon A, and this is just supposed to be any old arbitrary dragon, right? So if you're thinking of the start of the proof, it says, consider A, who's just any random dragon that you can think of, sort of like triangle ABC when we were talking about this last class. Furthermore, I have actually a very general structure for my proof already in place simply by recognizing that I'm going to do a universal introduction. I know that this subproof that starts on line 3 has to end with A breathes fire and A is a reptile because that's the consequent of the conditional that I want to prove. And from there I know my very next step is going to be universal introduction where the subproof starts on line 3 and ends with what I'm calling line X, which is wherever I manage to derive A breathes fire and A is a reptile. So note, this gives me a pretty clear proof strategy, right? I've sort of got the big picture of the proof in place, and I've just got to basically make my way from lines 3 to line X, and I've got the rest of the proof down, right? So the big picture is in place, and it's just connecting the dots at this point. So remember, we can apply proof strategies on iteration. We've essentially already done that to figure out how the last line of the proof is going to go, and now we can do that with the second to last line, which is the important subconclusion we need to prove. So the question now becomes, what's my main operator for line X? And what's the proof strategy? The main operator on line X is clearly the and, or conjunction. And the proof strategy is to try to get A breathes fire by itself and A is a reptile by itself. And we have some sense that we can get that with a little bit of massaging by getting it to the good stuff in lines 1 and 2. And it just takes a few steps to get there. I'll walk you through those now. Let's start with getting A as a reptile. So what I notice is I basically can do an arrow elimination, but it's going to take me 2 steps to get there. First, I've got to get line 1 to actually talk to line 3. And to do that, I have to use a universal elimination. So if all dragons are a reptile, then if A is a dragon, A is a reptile. That follows. And of course, by hypothesis on line 3, we know that A is a dragon. And so from that, we can then infer on line 5 that A is a reptile. And now we can do exactly the same thing with A breathes fire, right? We basically have to turn premise 2 into something about A. So if we know that all dragons breathe fire, then we know that if A is a dragon, then A breathes fire. Furthermore, by hypothesis, A is a dragon, right? And so we can infer, as we do on line 7, that A breathes fire. And with that, we have completed our proof. So let's just sort of talk through it as we would in English. Right? So we're given that all dragons are reptiles and all dragons breathe fire, and we want to prove that all dragons are therefore fire-breathing reptiles. So take any arbitrary dragon, call it A. Now since we know that all dragons are reptiles, we know that if A is a dragon, then A is a reptile, and we know that A is a dragon, so A is a reptile. Furthermore, if we know that all dragons breathe fire, then we know if A is a dragon, then A breathes fire. Since A is a dragon, therefore A breathes fire. And so because we know that A is both a reptile and A breathes fire, we know that A is a fire-breathing reptile. But there's nothing special about A. We could have done this with B, C, etc., etc., etc. So we know that it's an arbitrary individual or instance that we've taken. And we can generalize more broadly that all dragons are fire-breathing reptiles. And that's basically how we get to line 9. Okay, let's talk about existential elimination now. So existential elimination is going to be needed for something like the following inference. Some musicians are boxers, therefore someone is a boxer. And in case you don't know, that's Miles Davis. Now when I say it's needed for this inference, I want to be clear this is not an example of existential elimination yet. It's just you can't really make sense of it in a formal proof system without having existential elimination at your disposal. Now if you recall from the last lecture, the way that we discussed this informally was as follows. We had a proof and we just said, all right, we see that some musicians are boxers, so let's just call our boxing musician Mr. B. We just got to call him something. We don't know who it is exactly, given the premises. All right, now since Mr. B is a musician and a boxer, he's a boxer, and we can get that from and elimination. And since Mr. B is a boxer, someone is a boxer, and that's existential introduction. Okay, so here's the setup for the proof. Right, to translate our premise and our conclusion, we say there exists at least one X, such that X is a musician and a boxer. That's our premise. And our conclusion is there exists at least one X, such that X is a boxer. Now, as before, you have to get comfortable with a sort of strategic way of laying out the proof. This one works in more or less the opposite direction as universal introduction. There, if you recall, we looked at our conclusion, and that told us what to hypothesize. Here, what we're going to do is we're going to look at our premise, and that's going to tell us what to hypothesize. The way that I tend to think about this is premise 1 is sort of the inspiration for premise 2. And in fact, you can see then that there's actually a little easy mnemonic that you can put for the rationale that's going next to the conclusion. You put existential elimination, then your inspiration, which in this case is line 1, and finally the derivation, which is going to start at 2, and we'll see where it ends. Okay, another characteristic of existential elimination is that you're always going to sort of have an echo, is the way I think about it. That the last line in the subproof is going to be exactly the same thing as the claim that you're going to prove. And the crucial thing to keep in mind with this is we've hypothesized B, right? This is our boxing musician who we called Mr. B, right? We've hypothesized him on line 2, and we have to make sure that Mr. B doesn't leave the world of hypothesis. This is another Las Vegas rule, if you want to think about it that way. Is any name you hypothesize for either an existential elimination or a universal introduction can't leave that subproof if you're going to use the rules appropriately. So in this case, we know that the last line of the subproof has to be the very same thing as what we're trying to prove. It's got to be that there exists an X such that X is a boxer. And note furthermore that that tells us what the end of that derivation is going to be next to our conclusion, right? We know that line Y, whatever that ends up actually being, is going to be the last number that we cite in the final line of the proof. Note that we can just use reverse engineering all the way up on this proof, right? Our sub-conclusion on line y is there exists an x such that x is a boxer. So we ask, what's the main operator? It's an existential quantifier. And the proof strategy for this, I hope, is pretty straightforward. When you have an existential quantifier as your main operator, what you want to do is either do an existential elimination if there are existentially quantified premises, or if you have something like you have on line x, you're going to do an existential introduction, right? We know that basically there's going to be an easy way of proving that B is a boxer, and from there, of course, then someone is a boxer. And if you remember, this is exactly how our informal proof of this went. Okay, and then it's really simple to see how we get line 3, right? We get that through and elimination from line 2, right? And so if you, once again, think about the informal reasoning that's going on here, starting on line 2, it says, let's call our boxing musician Mr. B, right? Well, because Mr. B is both a musician and a boxer, clearly he's a boxer, right? But if Mr. B is a boxer, then someone is a boxer. And that's basically the conclusion that we get. And note that this mimics exactly what we did in English just a few minutes ago.
Thanks, and I'll see you at the next lesson.